All right, page 11 in your textbooks. Page 11, you did numbers 1 through 13 in the homework section. We'd already done the last little bit. We're taking care of these other ones. And most of us also have a number line. Some of us found a way to fit it in the book. Most of us did it on loose paper, which was probably good. We talked yesterday about different types of numbers. And we talked about counting numbers, and we talked about whole numbers, and we talked about integers, and I even mentioned rational numbers. You don't have to actually know that term. And we talked about positives and negatives and things like that. So we had a lot of different types of numbers. What they wanted you to do here on 1, 2, and 3 was tell what categories, counting whole, positive, negative, integer, would apply to each of these numbers. What did you write for number 1, for the number 55? Luciana?
Counting whole and positive.
It is a counting number. It is a whole number. It is a positive number. There's one more category it falls into, and that's because all whole numbers and counting numbers fall into this next category, class. Integers. Integers. Now, they also include negative whole numbers, like negative 55. That's an integer, even though it's not technically a whole number. But yeah, integer would be the 4. So 4 different things for number 1. How about number 2, the number 0? What categories does that fall into? As Michael put the bottle down on the floor there, Michael? Number 2, the number 0 is a whole number, and it's also, all whole numbers are, class? Integers. It's also an integer. How about number 3, negative 41.5? What do you have for that one, Jalen?
I have integer and negative.
Well, you're right about it being negative, but remember, I like integers and I don't like decimals and fractions. So if it's got a fraction or decimal on it, it ain't an integer. If there's not a fraction or decimal on it, it is an integer, and I like that. So just negative for number 3. Obviously 0, you couldn't put positive or negative because it's the dividing line, right? Does anyone remember what we call 0? Because it's right between the positives and negatives?
Origin.
The origin of that number line. For number 4 and 5, you're supposed to draw a couple of number lines here, and you can kind of pick how big or small you went. Notice the biggest number in the group is 8 2/3, or 7 2/3. So I at least need to get up to the number 8. So 1, 2, 3, 4, 5, 6, 7, 8. At least need to get that far. And the smallest number is a negative 3.7. So as long as I get at least to negative 4, maybe negative 5, I should be good. I'm going to actually apparently went out to negative 6. So again, doesn't have to be a huge number line, but draw something like this on your paper. And the first point you're supposed to plot was a 4. Well, that's not hard. Put a dot where it says 4. Negative 3.7 then, where does that go?
In between the 3 and the 4.
The negative 3 and the negative 4. So right in between these, which is it closer to?
The 4.
The negative 4, not 4, but negative 4. So we're going to put the dot right about here. How many had a dot right about there on your number line? The next one, negative 1. Of course, that's just at negative 1. No big deal there. And then 7 2/3, Ben. Where should that one go?
In between 7 and 8.
Good. Right in between these, closer to which one?
The 7.
7 2/3?
The 8.
Close, not a whole lot closer, but a little closer to the 8, right? So if right here would be 7 1/2, we're gonna go just a little bit closer to the 8 because 2 of the thirds of the way, right? Like if I walked from there to the back wall, I would say that maybe Paige is about a third of the way back and Corey's about 2/3 of the way back, and obviously all the way back would be to the wall, right? So 2/3 of the way I'm closer to the wall because I'm back where Corey is. Does that make sense? So that should have been where our 4 dots went on the first number line. On the next number line we drew. Let's see, I need to go, I don't need to go super small. I need to go up to at least 9 on the number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to label every 3. I don't like to put all the individual numbers because, you know, I'm lazy. All right. And negative 2.2, Ben, where should that go?
In between the 2 and 3.
Not the 2 and the 3. Negative 2 and
negative 3.
There you go. So in between these, closer to which one? Negative 2.2.
Negative 2.
Closer to the negative 2, just a little bit away from the negative 2. There we go. 8 1/5, Ben.
Close. In between the 8 and the 9.
Good, but closer to the
8.
Pretty close to the 8. In fact, the same distance as the other one was because 0.2 is the same as 1/5. How many remember that from 6th grade? We're going to cover that a little bit later in this class. 2, of course, is at 2, and 0, of course, is at the origin, or 0. How many had both number lines correct? You had all your points plotted correctly, no trouble finding points? Griffin, you were out yesterday. Do you have any questions on what we talked about with the number line? Does it make sense where we were putting these points? Negative 2.2 in between negative 2 and negative 3. And if you're starting at 0, negative 1, negative 2, negative 2.2, just a little further from the 0. 8 and 1/5. What did the professor say? 8 and a little fifth more. Does that make sense? So kind of think of it as starting from the 0 and either going negatively or positively. Again, there were some terms as I was going over the answers to 1 through 3, terms like integer, counting number, whole numbers, things like that. Some things you'll want to make sure you study on pages 8 and 9, or you can go back and watch yesterday's video lesson. I can send your mom a link and you can watch that and laugh at your classmates. Okay, you already have it. Good. All right. Let's take a look at numbers 6 through 11. What did we put in the blank? Did we put a greater than? Did we put a less than? Or did we put an equal sign? And what are those two vertical bars that are around some of these numbers? Sam, what's this?
I don't know the name, but I know it's just the number that's in it. They don't have the decimal or the plus.
The negative or the plus, the sign. It doesn't have a positive or negative sign. Yeah, so this means basically ignore the positive, negative. What does it actually mean? Like, what's the term for it? Elaine?
Absolute value.
Absolute value. Class, what does this mean? Absolute value. And it literally means distance from 0, but practically, Sam's right. Ignore the positive, negative. So for number 6, we didn't have to worry about absolute value here. Which is bigger, the negative 18 or the 3? Corey? 3 is bigger. Think of it this way. Would you rather have $3 or would you rather owe somebody $18? You know, you have nothing and you owe somebody $18. So when you finally make 18 bucks, you have to pay them to him, right? That's no good. I'd rather have 3 and owe nobody. So positive 3 is greater. So we should have put what symbol in the blank, Corey? Less than, right? The mouth should be eating the 3, so it should look like that. Number 7, which is the greater value, negative 4 or negative 20? Paige?
Negative 4.
Negative 4. Again, would you rather have nothing and owe somebody $4 or have nothing and owe somebody 20? Well, it's going to take longer to pay somebody back 20 bucks. You're not going to have any money to buy anything at Snack Cart for a while, right? So negative 4 is the greater. So what symbol goes in the blank page?
Less than.
Greater than. The mouth is eating the negative 4, right? So the greater than symbol. What about a number 8? What's going to go in that blank? Bryson?
Equal.
An equal sign. Now, negative 8 and positive 8 are not equal, right? You have $8, you owe $8, but their absolute values are equal. Number 9, what goes in that blank? Jalen? Greater than symbol. How about number 10? What goes in that blank? Ben? Greater than. What goes in the blank for number 11? Corey? Oh, another greater than symbol. So the whole bottom row, 9, 10, and 11 were all greater thans. All right, questions on those? All right, number 12. What is the value of the absolute value of negative 15, class? 15. And number 13, when you rewrote those numbers from the smallest number to the biggest number, in other words, you picture a number line, the first number on the number line working your way this way. What was the order of those numbers for 13, Michael? Well, negative 5 and 1/4. Good, negative 5 and 1/4 is the furthest this way, then negative 2, now you're passing 0 and you're at 1, and then 4.3. How many have those 4 values in that order? All right, any questions on that? Again, picturing the number line will help you there. Flip over to page 16, let's do some more review. You had the review, numbers 31 to 48, and let's see how we did on these. Number 31, which of those is a negative integer? Kirsten? Negative 19. Now, there are a couple other negatives, but they're not negative integers like negative 19 is. Number 32. In which of those categories, counting numbers, whole numbers, positive numbers, negative numbers, integers, would the number 97 not be included? Elaine?
Negative numbers.
It is all the others. It is a counting number. It is a whole number. It is an integer. It's a positive number. It is not a negative number. So that's our answer. It is not a negative number. Number 33. What whole number is not a counting number, Luciana?
0.
Good, and that helps you to define your whole numbers, right? It's all the counting numbers plus 0. So 0 would be the only whole number, not a counting number. What signed numbers are not integers? What would make something not be an integer? Corey?
Negative.
Well, there are negative integers, but what would make something not be an integer, Sam?
Fraction.
A fraction or, Jalen?
Decimal.
Decimal. If it has a fraction or a decimal, it's not an integer. So again, we don't like those, so I like integers. I don't like those. That would make them not integers. Number 35, a little bit of math for you. Find the cost to rent a bicycle for 9 days at a daily rate, that's a really cheap daily rate, of $10.89. Though by the time you've rented for 9 days, you probably could just about have bought a cheap bicycle. Paige, what'd you get for number 35?
$98.01.
Good and perfectly read, $98.01. That's the appropriate time to say and because that's where your decimal or fraction starts. Good job. Number 36, a little more math. Finding the sum of those 3 values. Elaine?
1,311.
And perfectly read, 1,311. Number 37, what is the definition? I've already said it a couple times today. What is the definition for absolute 0? Michael? See if you remember from what we said. Ben?
The 2 lines next to each other.
Well, that's how you show that you want absolute value. How's it defined, Luciana?
The distance of any number from 0.
The distance of any number from 0. Very good. Number 38 said to list any 4 integers. You really could have had a whole lot of things, but we're gonna let Michael make up 4 random integers off the top of his head. Don't overthink this now. He's thinking really hard about this. It should not take that much thought. Kirsten, you're laughing at him, so it's your turn.
-4, 8, -2, and 6.
Good. I like the variety too. -8, 4, -2, and 6. They were all even integers, by the way. So she had some negatives, she had some positives, but the main thing is she didn't say any fractions or decimals. All right, number 39. What kind of signed numbers are to the left of 0 on the number line page?
Negative.
Negative numbers. Number 40, rewrite that list, and there's 5 numbers there, from least to greatest. So again, picturing on the number line, starting furthest this way and going this way along the number line. How did you rewrite that list? And this time, let's get it from Sam. Wait. You didn't do it yet, did you? That's right, because you stopped at 38. Let's see. Elaine.
-9.
Well, -9.
-9. -1 1/4. 0, 5 1/6. 12.
Good. Now, it was just -1/4, but -1 and 1/4 would have been in the same order of those numbers anyway. So -9, -1/4, 0, 5 1/6, 12. And number 41, round that thing to the nearest 100,000. What did you have for that, Ben?
73,200,000.
Good. 73,200,000 and perfectly read. Great job. Number 42, check your blanks. Number 42, class, we should have put less than. Number 43?
Greater than.
Careful. -3 is greater than -23, but -3 is less than the absolute value of -23, right? Because what is the absolute value of -23, class?
23.
Just 23, yeah. Number 44, what should go in the blank, class?
Less
than. Number 45? Greater than. By the way, that's kind of like 43, right? But without the absolute value. So number 45 is greater than. Number 46, class? Less than. Number 47? Less than. And number 48? Greater than. Excellent questions on that. All right, flip back, if you would, to page 10. Flip back to page number 10. Let's do just a little bit more of that comparison on page 10. I want you to do 18 to 28, the even. Take just about 1 minute to do numbers 18 to 28, the evens, on page 10. Did you already finish? Overachiever. like most people are finished. And Griffin, I'm not picking on you, but since you weren't here yesterday, I want to make sure you got a good handle on this. So Griffin's going to give us his answers for 18 to 28, the even. What did you get for number 18? Negative 9 is?
Less than.
Negative 4. Number 20, 0.25 is?
Greater than.
Negative 0.301. Remember, a positive is always bigger than a negative. So you may be like, but I thought 0.3 would be bigger than 0.2. Well, it is, but not when it's negative. Positive is always bigger than negative. Good. Number 22.
Greater than.
Yeah, the absolute value of negative 23 is going to be greater than absolute value of negative 16. Number 24.
Less than.
Less than. Number 26.
Less. No. Yeah, less than.
Less than. Think about it. If you're on the number line, negative 1, negative 2, negative 3, negative 3 and a third is a little further left, which makes it a little smaller. So negative 3 and a third is slightly less than negative 3. Excellent. And number 28.
Greater than.
Greater than. Brecken was Sorry, I've been teaching him for a lot of years. Griffin was perfect. How many were perfect like Griffin? Any questions on any of those? All right, I want you now to do numbers 8, 10, 30, and 32. 8, 10, 30, and 32. Numbers 8 and 10, they've already drawn the number line for you. You just need to plot the points. Number 30 and 32, and picture a number line and write the order in which those values would appear. 8, 10, 30, and 32. People already finished with these? So make sure put the dots. Now, these ones we're kind of putting in order. These ones you're actually putting the dots on the number line. You actually have to plot these, just list the correct order. So rewrite them, which one would be first, second, third, fourth, is for Yes, ma'am. Well, 2/3, right? So picture a pizza. If you cut it in 3 or a piece of pie, you cut it in 3 pieces, and you took 2 of them, that wouldn't be all of it, right? That'd be less than 1, wouldn't it? So since it's negative, if you start at 0, you're not going all the way to -1, you're only going 2/3 of the way. Like when I talked about going to the back wall, that would be like going all the way to 1. But if I stop at U, that's 1/3 of the way. If I stop at Corey, that's 2/3. If I go all the way to the wall, that's 1. So here, -1 would be going all the way there. We're not quite going all the way there. Does that make sense? Same for any fraction that's a little bit less than 1. Pencils down, even if you're not finished with all of them. Number 8, we had 0. Nobody should have missed 0. 4 and 1/5. Well, we got 1, 2, 3, 4, but we're not done yet, right? We've got just a little further to go. How many went just a little beyond that 4 to 4 and 1/5? For the next one, -8. Well, that's pretty straightforward right there. But then -2.2, -1, -2, just a little past -2.2 there on number 8. How many had those points? All right, questions on that? Yes, ma'am. Oh, that's a lingering hand that you got. All right, let's take a look at number 10. In fact, I'm going to cheat and use the same number line if I can. It looks like I can. I'm going to use orange this time. 9. Okay, nope, I can't. 7, 8, 9. Okay, 9 will be the next to last line that they had there. Negative 2/3. This one Paige was just asking about. It may have given you some trouble as well. I'm going negatively, right? Because it's negative 2/3. But I'm not quite getting to negative 1. I'm going just a little bit shy of reaching that negative 1. Should have had a dot right about there. For 7.5, well, there's 6, 7, right as best you could, exactly midway between the 7 and the 8, and then of course 3, just there. Do we have those dots? The orange ones I've got pictured for number 10. Any questions on putting points on a number line? All right, and then for numbers 30 and 32, you weren't plotting them on the number line, but if you had been, what would have been the first dot furthest to the left as we started out? Let's see, Griffin?
Negative 12.24.
Then?
Negative 10.8.
And then we go all the way to
0.
0, and then finally we go into the positive side with
3.
3. Very good. By the way, of those 4 numbers, only one's an integer, class. Which one? 3. What do we call 0?
Origin.
Oh, see, I said only one. Excuse me. I said only one's an integer. That's 0 is also an integer. 0 and 3 are the integers. I'm sorry. 2 of them are integers. Only 1 is a counting number is what I meant to say, and 3 is the counting number. I'm sorry. But there was only one positive number. That was 3. That didn't go so well. My bad. And on YouTube forever. All right, number 32 for redemption for me now. What's the first number we should have listed, Corey?
Negative 5.5.
Good. Then?
Negative 2.
And then we go just a little into the positive side. 4/5, so not quite even to positive 1 yet, but we're on the positive side of 0, and then we go all the way to 7 if we've been plotting them. All right, how many had those for number 32? How many integers were there in this list, class?
1, 2.
2. Go 2. The negative 2 and the 7 were the 2 integers, and I'm not going to make fun of you, Jalen, after what I just did, so you know, you're safe. And the negative 2 and the 7 are the integers, and of course there's only one counting number in 32, class. 7 is the only counting number in number 32. Drop down to the bottom, number 40. They've got this problem for you. They've got a little 0.4. I think they might have a 0.4, but I'm lazy, so I don't write it. And then in the division house, they've got 286. What do we call the 0.4, class?
Divisor.
The divisor. Go ahead and write that in the blank next to the 0.4. That's called the divisor. D-I-V-I-S-O-R. What about next to the 286? What goes in that blank, class?
Dividend.
The dividend. And the answer, of course, is going to go on top. So what would we put in that blank?
Quotient.
The quotient. But if we wanted to do this division, class, we really can't. Not right now because of the decimal. So what do we got to do?
Move the decimal.
Move it one place. Where do we also have to move it?
In the divisor.
In the dividend, right? In the dividend. They didn't give you a lot of room. I kind of gave myself extra room, which basically when I move it, class, means we're going to add a 0. But because it's a 4, we know our 4 times tables, don't we?
Mm-hmm.
I can do this short division. How many times does 4 go into 28, class? 7. How many times does 4 go into 6?
1.
But there's still how many left over?
2.
How many times does 4 go into 20?
5.
And it goes in evenly, so we're done, and there's our answer. Of course, the decimal had moved back here, so it is 715 for our answer. Questions on that? All right, sit up, Corey. All right, go ahead and clear your desk of everything except for, if you would, a blank sheet of paper and a pencil. Clear your desk of everything except for a blank sheet of paper and a pencil. We're going to take another quiz today. We did fairly well on the last quiz. We're going to take another quiz today, see how well we remember these things we've been working on. So everything off your desk except for a blank sheet of paper and a pencil. Blank sheet of paper, pencil, every way. Quickly, quickly, quickly. This will be quiz 1. We took quiz 1A last time, so this is finally quiz 1. Even though it's the second quiz, don't ask me how that works. All right, take one, pass the rest back. I'm going to pass it back here. Go to put your first and last name in the name spot. First and last name in the name spot. And today's date in the date spot. First and last name in the name spot. Today's date in the date spot. Today is 8/23/23. 8/23/23. Yes, of course it did. Yeah, yeah, it did count. Yes, there will be periodically extra quizzes that I will work in throughout because I feel like they are beneficial for me to get a reading on how well you're doing. All right, 8/23/23 today's date. Let's take a look at this quiz together very quickly. Numbers 1 through 6, they have some different questions for you to answer. Okay, some different questions for you to answer there. Numbers 7 through 10, you're either going to put a greater than, less than, or equal to symbol in the blank. Then for 11 through 14, you've got one addition, subtraction, multiplication, and division problem to work out. The blank paper, remember, is for a cover sheet. You may use it to work on, but make sure you're also using it to keep your answers covered. Go ahead and get started on quiz 1. just another minute and a half or so to be finishing up. We're all finished here. If you're watching on video, you need a little more time, go ahead and pause and you can take another moment. The rest of us, however, are going to open up our textbooks to page 11. Page 11 in your textbooks. And we're going to talk a little bit today, more so tomorrow, about something called factoring. Factoring. Factoring has the idea of breaking something, a number specifically, into its parts. For instance, if I have the number 24, there's a few different ways I could break the number 24 up. I could break it into 3 times 8. What's another way I could break up the number 24, Sam?
4 times 6.
I could break it into 4 times 6. But there are other ways still that I could break up the number 24. Somebody else? Luciana?
12 times 2.
I could certainly do 12 times 2. There's one more way. It's kind of a cheap way to do it, but you know, it's still there.
24 times 1.
I'm sorry?
24 times 1.
Yeah, 24 times 1. You can always split a number into something itself times 1, right? But there's a lot of different ways to break a number into its factors. One of the hard things for students is thinking through all the possible factors that could be there. And one of the things that's going to help you to get this is if you understand what are called divisibility rules. And you see that on page 11. You see a table that lists some different rules for divisibility there at the bottom of the page. So we're on page 11. Page 11, stay with me. There's a little table there at the bottom of the page. These are indicated on the chart as well for those of you who can read the chart. I know the writing on it isn't super big, but there are several different divisibility rules. Now notice, there is not a rule that says that a number is divisible by 1. Why do you suppose that is? Elaine?
Because it's kind of obvious.
Yeah, everything's divisible by 1. If it's a number, it's divisible by 1, so we don't need to worry about that. But there is a rule for 2. A number is divisible by 2 when, Michael? When the number's even. Okay, what are even numbers? Well, they're numbers that end in 2, 4, 6, 8. Who do we appreciate? Anyway, when they end in 0, 2, 4, 6, or 8, it's an even number. So just look at the ending. Even numbers divisible by 2. If it's not even, it's not divisible by 2. Easy enough? 24, 2 is a factor because it's divisible by 2. It is an even number. If I put up the number 35, would this have 2 as one of its factors class? No. They say, well, you could divide by 2, Mr. Dasky, be 17.5. Right. But when we talk about divisibility, we don't want to mess with fractions and decimals. We want to deal with whole numbers, right? Integers. That's what we want to deal with. We don't want that. No. Okay? So 2 is not a factor because it's not even. Put a star next to 3. Put a star next to 3. A number is divisible by 3 when, Kirsten?
The sum of the digits is divisible by 3.
The sum of the digits is divisible by 3. Well, look at this. 24. If you take the sum, what does sum mean, class? Add. Sum is the answer to an addition problem. Sum implies addition. the sum of the digits. Now you say that number is 24, right? This has a value of 20, this has a value of 4. But the actual digits are a 2 and a 4, right? Like if you were putting this on a scoreboard, you would put up a number 2 and a number 4, correct? The digits are 2 and 4. The sum of those digits, 2 plus 4 class, is
6.
Can 3 go into 6?
Yeah.
Then 3 can go into 24. What's 3 plus 5?
8.
Does 3 go evenly into 8?
No.
Then 3 is not a factor of 35 any more than 2 is. 3 doesn't go in. The example that's listed here is the number 462. Well, what's 4 plus 6 plus 2 class?
12.
12. Can 3 divide evenly into 12?
Yes.
Yeah. Then 3 could divide evenly into this if we happen to check it out. We know that 3 is one of its factors, whatever the other one is. We don't really care enough to find it out right now. But 3 is one of its factors. Look at the rule for 4. A number is going to be divisible by 4 when, Ben?
The last 2 digits are divisible by 4 or are both zeros.
All right, so we see that here. And my chart didn't list that, so I added it there. When a number's last 2 digits are divisible by 4 or when it's a double zero. Now, this isn't useful for 2-digit numbers. That's not going to help you. But for bigger numbers, it is. For instance, they list the number 12,624. Well, all you really need to look at are the last 2 digits. 24. We know 4 is a factor of 24. Therefore, for this whole huge honking number, 4 is a factor. 4 times something, I don't care what it is, but 4 is a factor there. If I had the number 740, does 4 go into 40? Class? Yeah. Then it goes into 740. If I had the number 231, does 4 go into 31?
No.
Oh, then 4 doesn't go into 231. What if it was 232? Would 4 go into that number?
Yeah.
Because 4 goes into 32. Does that make sense? Look at the rule for 5. This one's really straightforward, and you kind of already know this because when you were little, you learned to count by 5s, didn't you? What's the rule for 5, Elaine?
The number ends in 0 or 5.
There we go. If it ends in a 0 or a 5, you know 5 goes in. How about 6? This is interesting. Put a star next to the rule for 6, class. And Griffin, read the rule for 6.
The number is even and divisible by 3.
If it's even, meaning it's divisible by 2, and it's divisible by 3, because what is a 6? A 6 is a 2 times 3, right? So to be divisible by 6, both 2 and 3 have to work. So if it's even, it's divisible by 2. If the sum of the digits allows it to be divisible by, well, let's see. What's 1 plus 2?
3.
Plus 6?
9.
Plus 2?
11.
Plus 4?
15.
The sum is 15. Can 3 go into 15, class?
Yes.
Yes. Is this an even number?
Yes.
Then this is divisible by 6. 6 would be one of its factors. And this way I don't have to actually try dividing by 6 to find that out, right? It could be a real shame to waste my time trying to divide by 6 only to find out, oh, it doesn't work. Well, this saves me all that time and trouble. I know 6 is going to work. I just would be a matter of actually doing the division. The rule for 9 is very similar to the rule for 3. Read that for us, Paige.
The sum of the digits is divisible by 9.
Now that's different. The sum of the digits has to be divisible by 9. If it's divisible by 9, will it be divisible by 3? Yes. What kind of numbers would be divisible by 9? Well, 9 is divisible by 9. 18 is divisible by 9. What else, class?
27.
27.
32.
Hopefully, we're not working a whole lot of huge numbers that are so big that if you add all their digits, it equals 36. Really, we're not going to work a whole lot of numbers whose digits add up to 27. I mean, that's a big number, and it only adds up to 15, okay? But unless the digits add up to 9 or 18 or maybe 27, it's not going to be divisible by 9. So, does 9 go into 15 evenly, class?
No.
9 is not one of the factors of 12,624. Does 9 go evenly into 12, class?
Yeah. No.
No. So 9 is not one of the factors. 3 is, but 9 isn't. What if I had 234? What do you get if you add these digits, class? 9. Does 9 go into 9?
Yeah.
Then 9 is one of the factors of 234, as is 3, because 3 also goes into 9. And it's even, class, so also 6. And since it's even, also 2. Does 4 go into 34? No, the 4 is not a factor. Does it end in 5 or 0?
No.
Then 5 is not a factor. The last rule is perhaps the easiest of them all. For 10, class, the number has to end in a 0. Okay, do we remember learning these in years past? All right, I'm going to give you some practice with this. I've got a handout for you. As always, it's in the description of the video. I've got the rules here on the handout for you as well, so that way you can set your books aside. Go ahead and clear that off your desk. Just have the handout out. And let's take a look at this. I want you to go through the box. Look at the first number. It's a 40. And figure out what you could divide the 40 by. Could you divide it by 2, 3, 4, 5, 6, and so forth? Or you could go down the column and say, which of these are divisible by 2? And check all them off. Which of these are divisible by 3? Check all them off, and so forth. At your seats, finish the box. Put check marks or X's for whatever it is divisible by. Couple people already finished. Take another 45 seconds and then I'll go over the answers. All right, let's be democratic about this. How many went down columns? You just picked out all the things divisible by 2, all the things divisible by 3, and so forth. I got 5. How many went rows? You looked at the number and found all the things it was divisible by. How many went scattered completely? Okay. I think the majority of those who had a method went columns, so I'm going to go by columns for you. Which ones are divisible by 2? You should have had a check mark next to 40, 120, 400, and 86. Those were your 4 things divisible by 2. Which ones are divisible by 3? Well, not 40. 4 plus 0 is 4. 3 can't go into that. 120? Yes. 1, 2, 0 adds up to 3. 3 goes into that. 611, 611 adds up to 7. Nope. 2 plus 8 plus 5 is 15. Yup. So next to 285, 4 plus nothing, nothing. No. 8 plus 6 is 14. No. 9 plus 2 plus 7 is 18. Yup. Put a check mark next to 927. And then 315. 315 adds up to 9. Yup. That also works. Then we go down to 4. I'm just focused on the last 2 digits. 4 goes into 40, yes. 4 goes into 20, yes. 4 goes into 11, nah. 85, nah. Double 0 always works for 4. 86, no. 27, no. 15, no. So only 3 check marks on the 4 column. The 5 column should have been easy. We all should have gotten 40, 120, 285, 400, and 315. What about the 6? Well, a quick way to do it is find any numbers that have check marks in both the 2 and the 3. And there's only one number with check marks in both so far, class. 120. It's the only one divisible by 6. What about 9? Well, the only ones when I was adding stuff up for the 3 earlier were the bottom two. 927 added up to 18. 9 can go into that. And 315 adds up to 9. 9 can go into that. So the bottom two numbers are the only ones divisible by 9. And then 10 should have been a piece of cake. Obviously 40, 120, and 400. How many had every check mark perfect? Anyone like that? Wow, a couple of you. How many had no more than 3 wrong check marks? Either something you needed to erase or add in. You had 3 or fewer incorrect. That's really strong. How many maybe 5 or fewer? You had 4 or 5 check marks? That's still not too bad. All right, we'll take a look at more of this in our next lesson. No homework this evening. Tomorrow we'll get more into factoring and then even how do we use and apply factoring. We'll also take a look at your quiz in our next lesson. Have a wonderful rest of your day. You are dismissed.